Let's look at this example now. So find the set of all real numbers x such that x squared equals -1. Well, if we go ahead and start solving this, we can take the positive and negative root of both sides. So you get that x is equal to the plus or minus root of -1. Well, what is the square root of -1? You may have learned that it's equal to this number called I. It's an imaginary number. Well, if it's imaginary, it's not going to be real. So again, there is no solution here where we have a real number x. So this is the null set. With sets, we've already been using the equal sign, but let's now formally define it with some of our notation and even some logic. So A equals B, set A equals set B, if and only if x is an element of A, then x is an element of B, and if x is an element of B, then it is an element of A. And this is a formal way to define when sets are equal. Notice with that formal definition, it didn't say anything about the order of the elements. So here we have A is equal to the set 1, 2, and 3, and B is equal to the set 3, 2, and 1. Well, is every element of A in B? Yes. And is every element of B in A? Yes. So does this definition hold? Yes, it does. So A equals B. Here in example 11, we are given that set A is equal to all x such that x is a whole number greater than 1 and less than 10. Let set B be equal to 2, 3, 4, 5, 6, 7, 8, 9, 10. So is A equal to B? I think the problem is this element, right? So then the whole numbers 2 through 9 are in set A, but 10 is not because it has to be less than 10. So 10 is not less than 10. It would have to say less than or equal to 10 in order for it to be included there. So always be careful and pay attention to the parameters, like the endpoints of the sets. So I've already used the word subset, but now I'm going to formally define it. So set A is a subset of B, is expressed symbolically like that. If and only if every element in set A is an element of set B. So basically you're creating set A from set B. And an analogy that you can use to help you remember, maybe you can think about it yourself, but what about less than or equal to? Okay, notice it's similar to that. This is my trick for remembering it. It's not what we call ordinal, though, so it's not literally less than, like on the number line, but it is similar to the idea of being contained within something smaller. Okay, so, but it will help you remember that the equals is also part of. So a set can be a subset of itself, and that's important. So if A equals B, then A is a subset of B, and B is a subset of A, because you can create each other from each other. In example 12, if A equals all odd numbers from 1 to 9 inclusive, and B is 1, 5, and 6, is set A a subset of B? Definitely not, because the amount of elements, which we'll call cardinality coming up to that, the size, the amount of elements in A is much larger. It can't be created from B. So this is no. And we can write it as A is not a subset of B. Well, is B a... Oh, and actually I noticed it's not all odd. They did stick the 6 in there. So is B a subset of A? Well, I see the 1, I see the 5, and I see the 6. So it is B is a subset of A, but this is what they were asking. So A is not a subset of B. In example 13, we're given that A is equal to the set 1, 2, 4, and 5, and B is the set 2, 5, 7, 9. So is A subset of B? Let's see. A subset of B, question mark. Okay, so let's see. Is 1 in B? I'm looking at the first one. 1 is not in B. So just because of that one alone, we can say no. But then it's asking us, is B a subset of A? Well, then that means, I'll use a different color here. Let's check. Is B in A? Yes. I'm sorry, if is 2 in A? Yes. Is 5 in A? Yes. Is 7 in A? Nope. So we can even stop right there, but 9 is also not. So this one is a no also. So these are what we call not mutually exclusive sets. So that will be defined later, but they have some intersections, but they are not subsets of each other. So far, we've been checking to see if sets are subsets of each other, but let's just actually list all of the subsets of a set. So given that the set A is equal to 5 and 6, what are the subsets? So first, I'm going to include both elements. That's a subset. And then I'm going to include only one. And then next I'm going to include the other one. And then last is not including any of them. So you can always think that each element can either be included in the subset or not. And we'll get to that soon, but if there's only 2 options, okay, so let me finish this. So if you're not including the 5 and you're not including the 6, what are you going to have? Nothing. Okay, so these are 4 subsets. And what I was almost getting at before, a little out of order, is that if there's 2 options for the element 5, which could be included, you're including it in the subset or not, and then there's 2 options for the second element, which is that you can either include it in the subset or not, then there's a total of 4 subsets. And we've seen this formula before, right? Where it's 2, when you're multiplying 2 by itself a few times. Do you remember when? Yes, when we were deciding how many rows were in the truth table, because how many options were there for each simple statement? There's only 2, right? So for like the statement P, there was true or false. And then for Q, there was also only 2 options, true or false. So again, that's why you end up getting this formula of 2 to the n is the number of subsets, where n is equal to the number of elements in the set. Here in example 15, we have to find all of the subsets of B, and B contains 3 elements. So for the first subset, let's use all 3. So we have the set itself. Then let's use the set of all of 2. So we can do it like that. So I'm omitting the 9. Now I'm going to omit the 8. Now I'm going to omit the 7. So then I have 8 and 9. So those are all of the 2 element subsets. And now we have the 1 element subsets. And then we have the last one is nothing. Okay, and you can write it as that, but it is not equal to this. Why? Because this is a set with 1 element in it. The element's name is the null set, or the element is the null set. But this is not equal to this set contains one element. So that should help you to see why this is not equal to the null set or empty braces. And let's use our formula again. So since we can either include the 7 in our subset or not, again, 8 either include or not, 9 include or not, we have 2 to the third or 8 total subsets. Sometimes we want to work with subsets that are not equal to the set itself. So only the subsets that are not equal. So when we call these proper subsets. And so the symbol that we're going to use is like a sideways horseshoe. So A is a proper subset of B if and only if set A is a subset of B, but, or you can say and, right? Set A does not equal B. Okay, and the analogy that you can use for this one is strictly less than. Because with the subset one, if you remember, the analogy I suggested was to help you remember this is less than or equal to. So this one you can just think of strictly less than, and that will help you remember that the symbol that we're going to use looks like this. It's that. In example 16, we have to list all the proper subsets of A, and there's 2 elements. So let's see, the number 2 to the second power means there's going to be 4 subsets. So what are they? They're the set itself. Well, that would be a subset, so I'm going to write it, but I'm actually going to cross it off as well, because this is not a proper subset. Okay, then we have the 1 element subsets, and then we have the null set. So we've got 4 subsets and 3 proper subsets. Right, so these are the 3 proper ones. Great job. In example 17, we have let C equal all X such that X is the color found in the American flag. So those colors are red, white, and blue. So we can actually write it like this: red, white, and blue. So there's going to be 2 to the third equals 8 subsets. So first we're going to list all of the subsets. So let's write all of them, all elements. I'm going to do the 2 element subsets. So there I'm omitting the B, then I'm going to omit the W, then I'm going to omit the R, and then we have the 1 element subsets. Sorry if sometimes my writing is not very neat. Trying. Okay, so we've got R, W, and B. And then the last one, do you remember what it is? You got it, the null set. So these are our 8 subsets. So this is part A, and then part B would be the same thing, except so you just omit the set itself, R, W, and B. Okay, and there you have it, the 8 subsets or the 7 proper subsets.